Hello, this is Neha. Chapter name is Light Reflection and Refraction from the class 10th. In the previous video, we already discussed about the definition of light, definition of reflection of light, as well as definition of plane mirror and properties of plane mirror. Today we move towards uses of plane mirror. Plane mirror are commonly used as looking glass and in making periscopes, kaleidoscopes, etc. Look at the diagrams, look at the pictures. First one is the plane mirror. First one is the looking glass. Means we are using the plane mirror as the looking glass. Second one is the periscopes. And third one is the kaleidoscopes. Looking glass, periscopes, kaleidoscopes, these are all made up of the plane mirrors. Okay. Next, we move towards spherical mirror. We already discussed in the previous video, that is the types of mirrors. First one is the plane mirror, second one is the spherical mirror. Then what is the spherical mirror? If the reflecting surface of the mirror is curved inwards or outwards, then mirror is called as the spherical mirror. Means spherical mirror means these are in the spherical shape, round shape. In that round shape, if the curved inward parts are the reflecting surfaces or curved outward parts are the reflecting surfaces, then it is called as the spherical mirror. They are of two types. First one is the concave mirror, second one is the convex mirror. These two are the types of spherical mirrors. Look at the picture. The first one is the convex mirror, second one is the concave mirror. Both are in the spherical shape only, but one mirror is, in that one mirror, inward part is, curved inward part is reflecting. And then one curved outward part is reflecting. This is the difference. Then concave mirror. The spherical mirror with inward curved reflecting surface is called concave mirror. Means concave mirror means this is also in the spherical shape. In this spherical shape, curved inward part is reflecting surface. And there one part is means outward part is polished here, inward part only reflecting surface. Then it is called as the concave mirror. Then second point, a beam of light generally converges after reflection from such surfaces. Hence it is called as convergent mirror. Means a concave mirror is also called as the convergent mirror, because when a beam of light falls on that mirror converges all the beam of lights after the reflection. Because of this converging nature, this mirror is called as the convergent mirror. Okay. This is the diagram. See, the outward part is there now. That outward part is polished. Inward part is only reflecting surface. When a light comes from this side, means when the light comes and falls on the inward part, that all the light ray will be reflecting back, and the reflected rays are convergent. That's why this mirror is called as a converging mirror. Okay. Next, convex mirror. Definition of convex mirror. The spherical mirror with outward curved reflecting surface is called convex mirror. This is reverse of the concave mirror, that's all. Means the convex mirror is also the spherical shape, spherical mirror. In that, the outward curved part is reflecting, the inward part is polished. Outward curved part is reflecting surface. That's why this is called as the convex mirror. Next point, a beam of light generally diverges after reflection from this surface. Hence, it is also called as the divergent mirror. Means when a light ray falls on the outward curved part of the mirror, all the light ray will be diverges. Because of that divergent nature, that mirror is also called as the divergent mirror. Look at the diagram here. This is reverse of the concave mirror. Here, outward part is reflecting. Inward part is polished, hard surface. They mentioned hard surface. Hard surface means that is polished. Outward part is reflecting part. When the light comes and falls on that surface, that will be reflect back. That reflection rays are divergent. That's why this mirror is called as a divergent mirror. Next, some definitions related to the mirrors. First one, pole. Pole. The center of reflecting surface of a spherical mirror is a point called pole of the mirror and usually represented by P. These definitions are related to both concave mirror as well as convex mirror, okay? In the mirrors, that may be concave, that may be convex. In that mirror, the center point of the reflecting surface, the center point of that reflecting surface is called as the pole, and this is usually represented by P. Then next, second point, center of curvature. Center of curvature of a spherical mirror is the center of the hollow sphere of glass, of which the spherical mirror is a part and is usually represented by C. Spherical mirror means in the sphere shape. When we are assuming that the sphere, the center of the curvature means the center line which is passing through the pole of the mirror, that center point is called as the center of curvature. Okay, once again I will repeat that one. Center of curvature of a spherical mirror is the center of the hollow sphere of glass, of which the spherical mirror is a part. Means when we are considering that mirror is the part of the sphere, then when we are assuming that is a sphere, the center point of that sphere is called as the center of curvature, and this is denoted by capital C. Third point, principal axis. The horizontal line passing through the center of curvature and pole of the spherical mirror is known as principal axis. The axis, the line, the imaginary line, which is the horizontal line, which is passing from the center of the sphere as well as pole, that line is called as the principal axis. Okay, the horizontal line or the imaginary line which is passing from center of curvature and pole, that is known as the principal axis. Next, fourth point, radius of curvature. Radius of curvature of a spherical mirror is the radius of the hollow sphere of glass of which the spherical mirror is part and is usually represented by R. We already know the radius of the circle. Same thing. The radius of curvature of the spherical mirror means the radius of the sphere. When we are considering the mirror, that mirror is as the sphere. The radius of that sphere is called as the radius of curvature. Then next one, aperture. The diameter of reflecting surface of spherical mirror is called its aperture. Aperture means when we are considering the mirror, the reflecting part, that diameter of that reflecting surface, the diameter of that reflecting part is known as the aperture. Next, principal focus. It is a point on the principal axis of the mirror at which the light rays coming parallel to principal axis after reflection actually meet. Principal focus means this is the point, this is the focus point, this is present on the principal axis. Principal axis means the line, the horizontal line which is passing through the center of curvature and pole. Okay, at that axis a point will be there. In that point, when the light rays, all the beam of light will be falls on the mirror, after the reflection all the light ray will be converging at that point. At that point is called as a principal focus. Once again I will repeat, the point which is located on the principal axis, at that point the light rays coming parallel to principal axis and after reflection they are actually meeting at that point. That is known as the principal focus. Next point, it is represented by capital F, means principal focus is represented by capital F. Then principal focus is different for concave and convex mirror. First one, for concave mirror, the focus is in front of the mirror. Means for the concave mirror, concave means the reflecting part is inward part. In that, the focus point is in front of the mirror. The focus point is located in front of that reflecting surface. For convex mirrors, the focus is behind the mirror. Means for the convex mirror means the outward part is reflecting. In that, the focus is located behind that reflecting surface. Okay. Next, focal length. The distance between pole and principal focus of spherical mirror is called focal length, and it is represented by small letter f. The distance between pole and principal focus. We already know that the focus means the point which is located on the principal axis. Okay. The distance between pole means the center point of the reflecting surface. The distance between the length between the principal focus as well as pole. The distance between or the length between the principal focus and the pole, that is known as the focal length. That is represented by small letter f. Okay. Wait. See the diagram. Convex mirror. First look at the convex mirror only. Convex mirror means the outward part is reflecting. They mentioned that the aperture. That aperture part is the reflecting. Another one is there, that is polished. Polished surface means the light ray cannot pass through that surface. Okay. The aperture part is only reflecting. In that aperture part, the center point is called as the pole. When we are assuming that convex mirror, that mirror is the hollow sphere. That time, the center of the circle is called as the center of curvature. The distance between that center of curvature and pole is called as the radius of curvature. Then principal axis means the horizontal line which is passing through center of curvature and pole. That is called as the principal axis. Clear? Next come to the concave mirrors. Look at the concave mirror. In that concave mirror, the inward part is reflecting. The outward part is polished. Okay. Outward part is polished. Inward part is reflecting. In that inward part, a center point is called as the pole. Same thing when we are assuming the concave mirror as the sphere, that time the center is called, center of that circle is called as the center of curvature. The distance between the center and pole is called as the radius of curvature. Aperture means the reflecting surface. Which is the reflecting surface here? Concave mirror. The inward part is the reflecting surface. That is known as the aperture. Same thing. Principal axis means the axis which is passing through the center of curvature and pole. That is called as the principal axis. Principal focus is located on the principal axis. Okay. I think you all are understood. If you got any doubt, please ask the doubts in the comment section or mail to the email ID. Thank you.